All right, today we're going to do lesson 7-4, subtracting fractions with unlike denominators. Rose bought the length of copper pipe shown below. She used half a yard to repair a waistline in her house. How much pipe does she have left? So what are we going to do here? She starts with 4/6 of a yard, and we notice they're both yards, and she's going to subtract out a half, and we're going to see what does she have left. Now we know, number one, just like with adding, are the denominators the same? No. So we have to go to number two. Can one denominator go into another? Yes. So let's write our problem. That's the best way to write them, is to stack them. So 2 does go into 6, so I'm going to leave 4/6 alone, and I'm going to turn 1/2 into 3/6, and now I can subtract. 4 minus 3 is 1, and I have 1/6 left. You can also use a fraction chart with that if you'd like. Okay. Next page. And remember, the video is available in Savvas. How can you subtract fractions with unlike denominators? Linda used 1/4 of a yard of the fabric she bought for a sewing project. How much fabric did she have left? So as we look through, we're going to see she wants to, let's go right over here, 2/3 minus 1/4. And the first thing we do, are the denominators the same? No. The second thing we do, does one denominator go evenly into the other? No. So now we have to do the third thing, which is find a common multiple. And common multiples of 3 and multiples of 4, the first one they have in common is 12. And like I said, I would start with the bigger one. 4, does 3 go into that? We already said no. 4 times 2 is 8. Does 3 go into that? No. 4 times 3 is 12. So you don't even have to do the multiples of 3. If you just start with the larger number and skip count or check your table and stop when you get to a number that the smaller number will go into. So they renamed the fractions. So 2/3, when you change it into twelfths, to get from a 3 to a 12, we're going to multiply by 4. Whatever you do to the bottom, you do to the top. Technically, what we just did was we multiplied 2/3 times 4/4, which is just multiplying it by 1, and we get 8/12. These covers the same amount of area. They're just cut into smaller pieces. And then 1/4, we want to turn that into twelfths. And remember, 1/4, 4 times 3 is 12. So we wind up with 3/12, subtract, and we get 5/12. Now things will get tricky when we have to borrow. That'll be coming up. But for now, we don't have to borrow. So the next page. In the example on page 390, is it possible to use a common denominator greater than 12? Sure, you could use a bigger number. You could use 24. You could use any multiple, any common multiple. You just have to reduce the fraction at the end. In the example on page 390, if Linda had started with 1 yard of fabric and used 5/8 of a yard, how much would she have left? And for many of you, you can do that in your head. 1 yard minus 5/8. If I want to represent 1 yard as eighths, it would be 8/8. So that one we can do pretty quickly. Because remember, the whole number 1 is equal to 8/8. The whole number 1 is equal to 8 pieces of 8. That equals 1 whole. Basic fraction concepts. Okay, now on number 3, the problem's written for us nicely. And they said 1, the denominators of 7 and 3, they're not the same. So 2, 1 doesn't go into the other one. 3, I'm going to have to find common multiple. And when you count by sevens, the first number you get that 3 will go into is 21. And in that case, you could have multiplied the denominator together to get that too. So they renamed the fractions. 4/7, they multiplied that times 3/3. 1/3, they multiplied it times 7/7. So they got 12 minus 7. So we have 5/21. For number 4, we have a 5/8. So let's see. Are the numbers the same? No. Does one go into another? Yes. That means we can leave one of the fractions alone. 4 goes into 8. So I'm going to leave 5/8 alone and change 1/4 into how many eighths? 4 times 2 equals 8. 1 times 2 equals 2. Now I can subtract and I get 3/8. For number 5, I do number 1. Are they the same? No. Get that over there. Are they the same? No. Does one go into the other one? No. So I'm going to have to rename both fractions. If you get to 3, you're going to have to rename both fractions. If you get to 2, you only have to rename one fraction. And if you're at 1, you don't have to rename any fractions. So 8 and 3, you can do the old school listing your multiples. 8, 16, 24, 3, 6, 9, 12, 15, 18, 21, 24. So you can see why I don't like this way. I like start with the bigger number, start counting, and check in mentally. 3 doesn't go into 8. 3 doesn't go into 16. 3 goes into 24. So now we have our new denominator. So 7/8 minus 1/3. 8 and 3 have 24 in common. And if you multiply the denominators, you'll always get a common multiple. So 1/3, to get from a 3 to a 24, we multiply by 8. 1 times 8 is 8. To get from an 8 to a 24, we multiply by 3. So we're going to multiply this whole fraction by 3 over 3. So we get 21/24 minus 8/24 is 13/24. And for number 6, no, they're not the same. 5 and a 6 are not the same. You can't, one number doesn't go into another, so they renamed both fractions to 30ths. And when you do subtracting here, 24 minus 5, you get 19/30. So there we go.